Hello students. In this video we're going to look at 4-6, which is regression and median fit lines. Now in the last video we watched, you had a scatter plot and you drew a line of best fit that you thought was correct, and then you figured out what the equation of that line is. Well, today we're going to show you how the calculator can do all of that for you and come up with the closest line of best fit possible. So a couple of things I want you to highlight are linear regression. Okay, there's an algorithm or a series of steps called linear regression that your calculator can do based on the data that you enter. And we're going to show you how to find that in just a second. The other part that you need to know is the correlation coefficient. A correlation coefficient is a number that tells me how close that equation of the line that the calculator calculated is to the sets of data. Now the correlation coefficient is a number between -1 and 1. The closer your number is to -1 or 1, negative because there's a negative slope, or 1 because positive because there's a positive slope, the closer it is to either one of those, the more accurate the line of best fit is. So if I've got a correlation coefficient of 0.97, that's really close to being absolutely correct. If my correlation coefficient is like -0.5, that's really not close to -1. So that means that probably that line of best fit is not as accurate as it could be. But that's the calculator's doing. And so sometimes it's just impossible to come up with an exact correlation coefficient because of the way the data is. Okay? We won't worry about why. We'll just figure out how to calculate it. So what I'd like for you to do is push the pause button in just a second, and I want you to read through this information. It's all stuff that we did in class with calculators, and I want you to just read through it really quickly to see how we found this information, and then we're going to come back and do something with it together. So now that you paused and read all of that information and figured out how to find each one of those items, let's look at a couple of examples and figure out why they plugged in 0 through 5 instead of the actual year numbers. When we have years like this, we don't want to actually plug in the number of years, because those numbers are just too big and throw off the data. What we want to look at is how far are these years from the first one. Well, the first year is 1999, so we're going to call that 0, because 1992 is 0 years from 1992. And then 1994 is 2 years after that, 1998 is 6 years after that, and then 2002 is 10 years after that, 2006 is 14 years after that, and 2010 is 18 years after that. So we're going to use those numbers when we use our calculator instead of the actual years itself. So let's plug those into our calculator really quick. I just happen to have my calculator handy, and I'm going to plug them in real quick. 0, enter. 2, enter. 6, enter. 10, enter. 14, enter. And 18, enter. I know you probably don't have a calculator at your house that you can do this, so I'm just going to plug in the data and hit a few buttons, and I'm going to let you write down the answers. In list 2, we're going to enter 5, 6, 6, 10, 9, and 9 to represent the number of gold medals we won in these Olympics in those years. And now I need to figure out what my correlation coefficient is and the equation of the line. So I know stat diagnostics is already turned on, so I'm going to go to stat calc, and we're going to go with linear regression model, which is number 4. So I go to number 4, enter 5 times, and there I'm given the slope, which is 0.25, the y-intercept, which is 5.41, and the correlation coefficient, which is 0.84. Now you're probably wondering about r squared. We don't do anything with r squared this year. All we're looking at is a, b, and r. So the equation for this line is y equals 0.251x plus 5.411. My correlation coefficient is 0.843 based on the data on my calculator. For time's sake in the video, we're not going to do this next one. We'll do that in class together when you have your calculator that you can use. Now the next part of this is finding a different type of line of best fit, and it's called a median fit line. They take all of the points in the data and they find the median of those points, and they create a line from that. Again, we're going to change the years to actual individual numbers. So 1980 would be 0, and then 4, and then 8, and then 12, and so forth. So I want you to again take a couple of minutes to pause right now, read this information, and then we're going to look at how we would solve it ourselves. So I'm going to hit pause, and I want you to pause, read it, and then you can start the video when you're finished reading that. So now let's look at the exercise number 1 about population growth. Okay, we've got a table estimating the population of Arizona in millions of people on July 1st of those years. So we're going to start with 2001, and that's going to become our 0 number. And then 1, 2, 3, 4, and 5, because that's the length of time since that 0 year, which was 2001. So let's plug this information in the calculator. So I go to Stat, Edit, and I'm going to clear the lists by going up to L1, clear, and enter. And now I'm going to type in 0, 1, 2, 3, 4, and 5. And now over here, we have 5.3, enter, 5.44, enter, 5.58, enter, 5.74, enter, 5.94, enter, and 6.17. Okay, I've got my data in, and now I want to find the median fit line. So I'm going to go back to Stat and Calc, but this time I'm going to choose number 3 because number 3 is MED for median fit line. And I hit enter 5 times, and there's my median fit line. Okay, so it would be y equals 0.171x plus 5.267. So that's the equation of the median fit line for this set of data. Now it asks me to predict the population of Arizona in 2009. Well, I'm going to show you a different way than what the page did up at the top to use the trace. We're just going to look at the table. But in order to look at the table, I've got to plug this information into my y equals window. Now, you can either write it down and memorize it, or we can go to the y equals button. I'm going to clear out whatever's ever there, and I'm going to ask the calculator what the information was. So I'm going to go to VARS, V-A-R-S, and we're using statistics, so I choose number 5. I'm going to go over to equations, and I'm still going to use number 1, which is the regression equation, and it plugs the information in there for me. And notice it doesn't round, it goes to a bit more accurate place value. And now to figure out what the population would be in 2009, 2009 is 8 years after 2001, so I'm going to find out where x equals 8, what is y. So I'm going to go to the table. If I hit, let me see if I can raise this up a little bit. If I go to second graph, that takes me to my table. And remember, I'm looking for when x is 8. So I scroll up just a little bit. So when x is 8, the y value is 6.6369. So we're going to round that to about 6.6. So to predict the population of Arizona in 2009, 6.6 million people, because it's in millions, according to the graph. That's all I need. And so what we're going to do tomorrow is do in class number 2 when you have a calculator and you could do it yourself. So what I need you to do now for your practice problems is just take a picture of the front and back of your notes page, submit that through Edmodo just so that I can verify that you watched the video, and then we'll do these other 2 problems together in class tomorrow.